All right, everybody, welcome back. We are continuing on to Module 6.3, and we're continuing to look at these major domains that comprise prokaryotic life. So we talked last time about bacteria, and now we're moving on to the domain Archaea. So I wanted to start off by looking at an interesting study by Jose de la Torre, who was looking at life that exists in these sort of extreme lakes um, that have extreme heat and are methane producing. And interestingly, he's able to classify the types of life that can exist in here. The green are the bacteria, but you can see that the vast majority of life that exists in this extreme environment is actually archaea. So these are archaeal organisms in red. So when we're talking about archaea, again, we're going to start this sort of looking at where we're at on this tree of life. So we have bacteria and eukarya. So archaeas are actually more closely related to eukaryotes than bacteria. And when we're talking about archaea, we're really talking about a subgroup that is classified primarily by extremophiles. So basically life that live in these very extreme environments. And they're very similar to bacteria, at least structurally. They lack a nucleus. However, they're very genetically distinct. And again, they're really classified by being what we call extremophiles. So we have a couple subclassifications where we have hyperthermophiles. So we have basically, again, if we sort of break it up by the Latin and Greek roots, hyper more meaning more, thermo meaning heat, and philes meaning loving. Hyperthermophiles, we have an organism that loves heat. So these are organisms that exist in extreme heat environments, like those in those hydrothermic vents that we examined in our chapter. Next, we have methanogens. So these are organisms that live in extreme and are able to digest methane. And then we have halophiles, or salt-loving organisms. So an interesting example of looking at that methane causing is looking at the prokaryotes that survive, again, in the lost city. So your book gives us sort of an excellent example looking at how these bacteria actually eat methane, and then these types of archaea are also able to survive in these extreme environments because they're able to eat these methane. So this is just sort of a good example of the systems that exist for archaea and also some bacteria within these very extreme environments. And ultimately look very different than the life cycles or food webs that other bacterial, for example, or eukaryotic organisms might display. So I wanted to give you some examples of where archaea can live. So for example, we have this river called Spain's Rio Tinto, which is extremely acidic and full of heavy metals, but there are lots of microorganisms, including archaea. Another example, which we've been talking about extensively, is again those hydrothermic vents. We're having surrounding water reaching 3 times the boiling point of water, and yet again life is able to persist in this extreme environment. And so from extremely hot, we also have extremely cold and ultra salty lake in East Antarctica, again home to Haleo archaea. So again, salt-loving organisms. So ultimately, while their structure is decidedly unique, what ultimately makes this clade unique is its ability to survive in these what we would consider very strange environments, or environments that would be devoid of life, but we now know contain many microorganisms. So to sum up sort of prokaryotic diversity, the first thing we have to acknowledge is prokaryotes are unicellular organisms. They lack those internal organelles, and the DNA is not contained by a nucleus. Prokaryotes are found in virtually every environment on Earth, and that was really exemplified by this last lecture, looking at those extremophiles living in adverse environments. And ultimately, you know, when in terms of placing us on the genetic tree, the genetic analysis of the categorization of life can really be divided into these three domains: bacteria, archaea, and eukarya. And we're going to be starting to dive into eukarya with plants in our next lecture. Both the bacteria and archaea are prokaryotic cells, but are otherwise different in their structure, their biochemistry, and their lifestyles. Bacteria are a diverse group of prokaryotic organisms with many unique adaptations, such as flagella, capsules that allow them to live and thrive in many environments. However, archaea really are those organisms that live in the most inhospitable conditions on Earth, such, again, as those hydrothermal vents. Okay, great. Go get some water, take a rest, come back, and we're going to start talking about plants and eukaryotic organisms.